Today, we're going to delve into the world of RAID systems, which stands for Redundant Array of Independent Disks. These systems are a fundamental part of modern data storage, providing both increased performance and improved reliability. Let's get started by understanding what RAID is and how it works. So, what exactly is RAID? Simply put, it's a technology that combines multiple physical disk drives into a single logical unit. This combination allows for data to be distributed and managed in a way that offers several key benefits. These benefits include data redundancy, which means that data is duplicated or distributed in a way that protects against data loss in case of drive failure. Performance improvement: by spreading data across multiple drives, RAID can significantly increase read and write speeds. RAID also balances reliability, availability, performance, and capacity to meet different storage needs. Data is distributed across the drives using different methods which are known as RAID levels. A RAID controller manages how data is written to and read from the array of disks, optimizing performance and ensuring data integrity. Let's explore RAID 0, also known as striping. In RAID 0, data is divided into segments and spread across multiple disks. This means that when reading or writing data, multiple disks are working simultaneously, leading to improved performance. Reads and writes are spread across multiple disks to improve the read and write speeds. With RAID 0, you get 100% storage efficiency since there is no redundancy. The full capacity of all drives is used. But there is no fault tolerance. If any drive fails, all data is lost. The best use case is for the non-critical data that requires high performance, such as gaming or video editing where speed is crucial and data loss is tolerable. Next up is RAID 1, which implements mirroring. In RAID 1, data is identically copied onto multiple disks. This provides high fault tolerance because if one disk fails, the other disk contains an exact copy of the data. Reads are also improved because data can be read from multiple disks simultaneously. The write performance is the same as a single disk since all copies must be updated. You get 50% storage efficiency, as half of the total capacity is used for redundancy. It is a suitable choice for applications where data protection is paramount, such as operating systems or critical applications. RAID 5 employs striping with Parity. Data and Parity, which is an error correction code, are striped across all disks. In this setup, the failure of any single disk can be tolerated because the Parity information can be used to reconstruct the missing data. The read performance is good, similar to RAID 0, because data is striped across multiple disks. However, write performance is reduced because Parity calculations add overhead. Storage efficiency is calculated as n-1 divided by n of the total capacity, where n is the number of disks. This means one disk's worth of space is used for Parity. Parity is distributed across all disks to avoid bottlenecks. It is commonly used in general-purpose servers and database applications where a balance of performance and reliability is needed. RAID 10, also known as RAID 1 plus 0, is a nested RAID level that combines mirroring and striping. It first mirrors the data and then stripes it across multiple mirror sets. This provides both high fault tolerance and excellent performance for both reads and writes. It can survive multiple disk failures, as long as no mirror pair loses both disks. You get 50% storage efficiency, as half of the total capacity is used for redundancy. It is often used in critical applications that require both high performance and redundancy, such as database servers and transaction processing systems. At least 4 disks are needed to implement RAID 10. Now, let's compare the different RAID levels based on several key factors. Starting with RAID 0. It requires a minimum of 2 disks and has no fault tolerance, but offers excellent read and write performance and 100% storage efficiency. It is best used for temporary data or performance-critical non-essential data. RAID 1 requires a minimum of 2 disks, provides good fault tolerance, good read performance, and fair write performance, with 50% storage efficiency. It is commonly used for operating system drives and critical data, requiring redundancy. RAID 5 requires a minimum of 3 disks, offers fair fault tolerance, good read performance, and fair write performance, with storage efficiency of n-1 divided by n. It is often used for general-purpose servers and database applications. RAID 10 requires a minimum of 4 disks, offers excellent fault tolerance, excellent read performance, and good write performance, with 50% storage efficiency. It is ideal for high-performance database servers and critical applications. It is important to remember that RAID 10 can survive multiple disk failures, as long as no mirror pair loses both disks. Selecting the right RAID level involves several key considerations. The first one is performance requirements. Understand the workload and the IOPS requirements. If you have an application that requires high amount of reads but less writes, then you should select your RAID levels accordingly. Second consideration is data protection. Evaluate the criticality of the data and what is the acceptable downtime. Some applications need high uptime, so you need to consider all the factors to select your RAID level. The third consideration is cost factors. Determine your hardware costs and how many number of disks you need. Also consider the storage efficiency and power consumption of the disks. The fourth and last consideration is implementation factors. Determine what type of RAID implementation you need. Hardware implementation or software implementation. Also, keep in mind the scalability and future expansion needs. Compatibility with existing infrastructure is also an important factor. The optimal RAID configuration depends on balancing these factors based on specific use case requirements. In summary, RAID provides data redundancy and/or performance improvements through disk configurations. Different RAID levels offer varying balances of performance, redundancy, and capacity. RAID is not a backup solution. It protects against hardware failure, not user errors or disasters. Selection should be based on specific workload requirements and business needs. Modern systems often use combinations of RAID levels or software-defined storage solutions. Now let's talk about some of the best practices of RAID systems. You should always use identical drives for optimal performance. Implement regular monitoring and proactive drive replacement. Keep spare drives available for quick replacement. Maintain regular backups independent of RAID system. Use battery backup or UPS to protect against power failures. Document RAID configuration for disaster recovery. Test recovery procedures periodically. Remember, RAID enhances reliability, but is not a substitute for a comprehensive backup strategy. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.